Okay, so we are starting with we're reviewing for the Chapter 10 test, and we are starting with looking at some of the 10-4 GGA questions. So if you could all take out your 10-4 GGA. Many people struggled, particularly on problems 7 through 12. But let's just take a look at a few of these. If you're looking at problem number 1, for example, and can I also ask that you take out your unit circle? You will be given a unit circle to use on the test, and so you do need to be able to use it, though, right? So, for example, let's take a look at number 1. Number 1 says sine inverse of negative square root of 3 over 2. What does this mean?
I don't know.
All right, so on the practice test, and possibly on the real test, there will be a question for you to translate what this means. All right, the translation is the angle whose sine value is negative square root of 3 over 2. So this is the translation of what this means.
I got a question. Are we gonna get the circly thing on the title? Like you're gonna give us one of those?
I just said that.
I'm just double checking.
Okay, so on your unit circle,
Can I use mine because it's pretty?
I think we'll be probably giving you one for this. On, all the more reason for us to give you one.
Cheater.
Right, so on your unit circle, where is the sine? What angle has a sine value of negative square root of 3 over 2? 150 degrees. Do people agree?
Yeah.
All right. What is that in radian mode? 5 pi over 6. Do people agree with that?
Yes, if you look at your unit circle.
But the sine, hang on a second, the sine is the y coordinate.
This is so ugly.
Leah, the sine is the y coordinate, not the x. So do you want to revise your answer? Cameron, how much?
300 degrees.
I don't want to smell you, Connor.
300 degrees?
Yeah, and then it's 5 pi over 3.
Or 5 pi over 3 radians?
Right.
On our unit circle, that's going to be putting us right down here where the ordered pair at 5 pi over 3 is 1/2 comma negative square root of 3 over 2.
Correct.
Where else is the y coordinate negative square root of 3 over 2?
It is also the y coordinate negative. Okay, because I wasn't talking about 240 degrees
No idea
or
what
4 pi over 3.
So 240 degrees, which is over here, that's 4 pi over 3, because that has the order pair negative 1/2 comma negative square root of 3 over 2. So our answer for this first problem, what is the sine inverse of negative square root of 3 over 2, is going to be here at 5 pi over 3 and here at 4 pi over 3. So those would be the two answers you would give, 4 pi over 3 and 5 pi over 3. If you want to give them in degree mode also, you can. I'm more interested in the radian mode. All right.
So two lines that are basically opposite each other, the y-axis are going to have the same.
Are you asking why it's this point and this point on the unit circle? Because we're looking at our unit circle and we see that those are the two that have a y coordinate of negative square root of 3 over 2. All right, let's switch gears and talk about number 7. For number 7, it says find capital sine inverse of negative 1. The translation for this is a little bit different because of the capital X. The translation for this would be what angle between negative pi over 2 and pi over 2 has a sign value of negative 1. So you look at your unit circle, but this time you're only looking on the right side of your unit circle, not the whole unit circle, and you've got to be looking only between negative pi over 2 and pi over 2. Capital sign inverse will only have one answer, not a bunch of different answers. Leah?
Why is it negative pi over 2? And
Because mathematicians want to have an inverse for sine, and if we just said what angle has a sine value of negative 1, there's going to be lots of different answers, and we can't have that. If we want an inverse, there should only be one.
so
Right.
we always use negative pi over 2 and pi over 2?
For capital sine inverse and for capital tangent inverse, we use negative pi over 2 to pi over 2. For capital cosine inverse, we use a different range from 0 to pi, and only the top half of the circle. Lexi?
Why do you only use the right side of the circle?
Because mathematicians have agreed that we will just look on the right half of the circle, and not just on the right half. You want to say from 0 down to negative pi over 2, and from 0 up to pi over 2. So for example, when you give an answer for this, and I know you've got on your unit circle, it says what, 11 pi over 6 here? You with me? But you would not give that as an answer for a capital sine inverse. Instead, you're picturing this angle, which would be what? We're not going around this way. We don't want to go this way. That would be 11 pi over 6 or 330. We don't want that. We want to go this direction. It's just going to be negative pi over 6. Negative 30 degrees, right? But we'll give it in radian measure, which is negative pi over 6. So go ahead on your unit circle, and I wouldn't cross off the 11 pi over 6, but right next to it, negative pi over 6. Does that make sense? So if you want to find the capital sine inverse, you'll give negative pi over 6 as your answer, perhaps. Or what's this one going to be?
So basically
Instead of 7 pi over 4, you could also
pi over 4.
take 7 pi over 4 and subtract 2 pi, because we're going around the unit circle. That's 7 pi over 4 minus 8 pi over 4, which is what?
1 pi. Negative 1.
Negative pi over 4. So that answer you might want to list as negative pi over 4 if you're giving an answer for a capital sine inverse of negative 1. Jenna? Yes.
So we always use the right side of the circle, which means, but on our unit circle, on the bottom, it doesn't say negative pi over 2, it says 3 pi over 2.
Correct. But again, when you're answering a question like what's the sine inverse of negative 1, you're looking where on the right half of the circle is your y coordinate equal to negative 1. So you would say, hey, that happens down here where the order pair is 0, negative 1, right? But you would not want to give 3 pi over 2 as your answer, because 3 pi over 2 is not in this interval from negative pi over 2 to pi over 2. You would have to give this angle right here, which is negative pi over 2.
So for capital sine and capital cosine, we always use that area for the circle.
For capital sine inverse and capital tangent inverse, they both use this
Part of the,
right half of the circle.
but then the cosine and the
Capital cosine inverse uses just the top half of the circle from 0 to pi. All right, so let's go back to this one for a minute. So we are okay with our answer for capital sine inverse of negative 1. Your answer should be negative pi over 2, because that is the angle between negative pi over 2 and pi over 2 that has a y coordinate of negative 1, because there's my order pair, 0, negative. All right, let's do one more of these capital sine inverses before we go on. Was there another one? Nah. I mean, there's number 10, but that's a positive one. So what angle, what angle, for number 10, what angle has a sine of square root of 3 over 2, but it has to be here on the right side of the unit circle? So 60 degrees or pi over 3, that's up here. Pi over 3 is here. The ordered pair is 1/2, comma, square root of 3 over 2. So your answer for number 10 should be pi over 3 and 60 degrees.
Why coordinate? Why not X?
The sine is the y coordinate.
So is the cosine
And do we need to-
Cosine, yes.
And the
Cosine is the x coordinate.
tangent is the y.
Y over x. Tangent is y over x. So let me ask one more about sine inverse. How about a capital sine inverse of a negative 1/2? What's your answer going to be for this one? I know this is not on your,
330. No. 60.
so capital sine, so
It is pi over 6.
Whose side is that?
so is it negative pi over 6? Negative pi over 6 here has the ordered pair, what? Square root of 3 over 2, comma, negative 1/2, right? So that's the one we want. So our answer is going to be negative pi over 6 for this. If you gave me 11 pi over 6, that would be wrong.
Okay, what if we gave you 60 degrees?
If you gave me 30, if you gave me negative 30 degrees, that would be okay.
So you would do the negative.
But we would want it to be negative pi over 6 because we're going in this direction. We're going clockwise, which is the negative direction. All right, so let's, thank you. Let's go on and answer any questions with the other GGAs. Anything else we should look at from the other GGAs you got back?
No, I'm good.
No, let's start with the practice test.
Why was this wrong though? This is what I don't.
Okay, so we are now going over some of the problems on the practice test. In particular, we're going over, which one, number 19? All right, so for number 19,
Oh, I thought we were doing equal.
number 19 is here. And for this problem, pull this up a little bit.
Oh, here we go.
Oh no.
All right, for this problem, it says a railing along an observation deck at an aquarium has a length of 22 feet. The railing is shaped like an arc that represents 1/8 of a circle. Well, 1/8 of a circle would be 1/8 times 360, which is 45 degrees, which is the same as pi over 4 radians. Then it says to the nearest foot, what is the radius of the circle on which the railing is based? So picture that you've got this arc right here, which is 22 feet long, and you know that this angle here is pi over 4 radians, and you are trying to find this radius that it's based on. All right, we'll call that r, and we're going to use the formula s equals r times theta. This formula only works if your angle is in radians, so do not try to plug in 45 degrees here. So you're going to get s equals r times pi over 4, and we know that the s is actually 22. S stands for arc length. That was not nice.
S equals R for it.
So S represents arc length, yes. So then we have 22 equals R times pi over 4. So to solve for R, we get 22 divided by pi over 4. And this is a real world problem, so it's okay to give a decimal answer. It turns out to be about 28 feet. So the radius is about 28 feet. All right?
Will you get the same answer if you forget to put the degrees?
If you plugged in 45 here, you'll get a completely different answer, and it will be an incorrect answer. All right, what else should we look at?
What if you put the degrees forward, or 25 degrees?
I don't think so.
How can you check?
You've got to have radian measure.
Can you check it? Like your answer?
I don't know if there's a way to check that one. All right, what else should we be looking at? 25? All right, for number 25, it says a driver uses a ramp when unloading supplies from his delivery truck. The ramp is 10 feet long and the bed of the truck is 4 feet off the ground. So this was my sketch, not a very good one, but this is part of the truck. There's the wheel of the truck and so on. Here's the ramp that's coming out the back.
Such a good drawing.
And we know that the ramp is 10, and we know that this height right here is 4. We're trying to find this angle theta because it says find the angle that the ramp makes with the ground. And so in this case, we know the opposite side is 4, we know the hypotenuse is 10, and we're going to use SOHCAHTOA,
Sine.
and that tells us we want to use sine because we know the opposite, we're trying to find the hypotenuse. Right?
Okay, but then you
Wait, did I say that right? Oh, no, we know the opposite and the hypotenuse. We're trying to find the angle. My bad. All right. So that sine of theta is opposite over hypotenuse, so sine of the angle theta is 4 over 10. That means we're trying to find the angle whose sine value is 4/10. So we write that as theta, the angle, is going to be sine inverse of 4/10. On my calculator, which is set up in radian mode, I got 0.4115, and that's radians. Then I converted that to degrees by doing 0.4115 times 180 without a degree symbol over pi, and I ended up getting 23.58, which is, if I'm rounding to the nearest degree, is about 24 degrees.
180 over pi.
If you're given radians and you want to convert to degrees, yes, you multiply by 180 over pi. What else shall we look at on this practice test? Yes.
I actually did this a lot. Now that I look at it, I get it.
All right, what other one shall we? 29?
31.
All right, let's look at 29. All right, this one says use the measurements to solve each
Wow,
Isn't that just a squared plus
triangle.
It's a lot of stuff right there.
That's a lot of writing that I squished in here.
but it's good writing.
I hope. Let's take a look. So for this picture, I am using law of cosines for this because law of sines will just not work, right? Because I do not have any angle across from a side that I can work with. I have SAS situation, which is pointing you to law of cosines. So in this case, I'm going to try and find side A by using the law of cosines that says a squared equals b squared plus c squared minus 2bc times cosine of A.
This will be provided on our test.
Law of cosines will be provided on your test.
Why isn't it a squared plus b squared equals c squared?
A squared plus b squared equals c squared is only good for right triangles. This is not a right triangle, but that was an excellent question, Leah. You got this.
I want to pause.
Come on.
All right.
Pretty good question.
So, Jeff. Yes. So then you're going to fill in your b squared, your c squared. So you get 15 squared plus 21 squared minus 2. Minus 2 times 15 times 21 times cosine of 85. This is all calculator work. I ended up getting a squared equaling 611.092. I took the square root, and I got the side A as 24.7. Now, so if I get this side here as 24.7, whatever the linear units are that we're using, I now need to find either angle C or angle B, and it's very important to find the larger one first. All right, so out of angle C or angle B, which one is going to be larger?
C,
Why C?
because
Side C?
side C is 21.
And side B is 15. So we're going to go with, we're going to find angle C first. So we're going to say cosine of angle C equals, now remember this is also your law of cosines, but it's the different format. This is if you're trying to find an angle. This one here was if you were going to try and find, this one here is if you're going to try and find a side. This is if you're going to find an angle. So cosine of angle C is a squared plus b squared minus c squared over 2ab,
Which is also provided on our test.
which will be provided. And so I plugged in 24.7 squared plus 15 squared minus 21 squared. over 2 times 24.7 times 15. I ended up getting 0.5318. That's the cosine of angle C. So here's my arrow leading us this way. So that means to find angle C is going to be cosine inverse of 0.5318. Again, my calculator set up to radian mode, so I got 1.01 radians, which turns out to be 57.9 degrees. So now we have angle C. We already had angle A, so we can just subtract to get angle B, and I got 37.1
I
degrees.
have a question.
Yes.
So in order to get the cosine of capital C, you have to use the inverse. Then if you get the radians, you have to transfer it over to degrees by doing 180 divided by pi.
Times 180 divided by pi.
Right. Okay.
Exactly. All right, what else should we look at from the practice test? Do you want to do some evens or any more odds? Well, I just want to record a few more.
Okay.
So what else? Which other ones look tricky on here? 28. Number 28.
Oh, God.
Come on. When Miss Jenny comes back. All right, so for this one, you are asked to draw a sketch and solve the triangle. A is 7 inches, B is 3.5 inches, and the measure of angle A is 130 degrees. And so with that in mind, this time I was able to use law of sines because I did have given to me an angle and the side opposite it. That's kind of the recipe for having being able to use law of sines. So I said sine of A over A equals sine of B over B. So that gave me sine of 130 degrees over 7 equals sine of B over 3.5. And I cross multiplied and I got 7 times sine of B equals 3.5 times sine of 130. I divided both sides by 7 and I get sine of B is equal to 3.5 times sine of 130 over 7. And so with that in mind, I just plugged that into the calculator. I ended up getting sine of B equals 0.383. And then to find angle B, that means I want the angle whose sine is 0.383. So I got to do sine inverse of 0.383. My calculator set in radians, so I got 0.39307 radians, which I multiplied by 180 and divided by pi to get 22.5 degrees. And then to get my last, what did I do? And then I got angle C by doing 180 minus 130 minus the 22.5, which I then have is 27.5 degrees for angle C. And then did I finish this or did I stop? I set up what I needed to find my last remaining side, which is this side, C, here, right? I now know that this angle is 27.5. And I got this angle is 22.5, so I have the setup here for finding side C. It's sine of 130 degrees over 7 equals sine of 27.5, that's this angle, over the side opposite it. So did I have that done or not? Wow, looks like I stopped. I quit working.
That's not grit.
That's not good. There was no
You
grit
did not
there.
use the grit there, Miss Hessig.
Apparently, I stopped on that. So, so I'll let you finish this one up. Cross multiply, you get C times sine of 130 degrees equals 7 times sine of 27.5 degrees, right? Divide both sides by sine of 130. Oh, wait a sec. Oh, yeah, I was supposed to solve the triangle, so I do need to do this. So I end up getting C equaling 7 times sine of 27.5 degrees over sine of 130 degrees. Everybody agree? I'll let you finish this one up. Anything else that we should look at from the practice test? Lexi,
You're kidding me.
other questions?
You can't do,
I
E squared
see
plus
it.
B squared equals C squared on that one?
Not unless it's a right triangle. A squared plus B squared equals C squared only works for right triangles.
No dumb question.
Stop asking those kind of questions, Connor.
Which one?
Can I have a pass?
Oh, you got the answer? What did it turn out to be?
Oh, okay.
4.2? Do people agree with that? 4.2 inches? Awesome.
Can I have a pass?
Any other questions on the practice test?
Hey, yo, what up?